Great. So my name is Flávio Juvenal, and I'm a partner and chief scientist at Vinta Software. And that fancy name, chief scientist, means that basically I'm the person who like studies good practices and keep in touch with like the state of the art on the industry related to the tools that we use. And I've been working with Django for since 2010 or 11. So a long time up to now. And I've been working a lot with Celery as well, which is the main asynchronous task framework used with Django, right? So I want to talk with you today about mixing reliability with Celery for delicious async tasks. And the idea here is to give like an overview and a deep dive on like Celery reliability. So if you are a beginner with on Celery, um, there's a lot in this talk that perhaps you won't get at first, but at least you know that the concept exists or that problem exists, and you have to consider that as you dive deeper into Celery projects. So hopefully this will serve as a reference for everyone, for the less experienced to the most experienced folks that are working with Django and Celery. Okay, and I will accept questions at the end. So you can also download this presentation slides at this link, vintasoftware.com/Django talks.
My slides are
Cool.
available in that link too, you?
Yeah.
Right?
Hugo's ones are here as well. Uh, So, like I said, I'm already assuming like you kind of use Celery or you know Celery basics on this talk. If you don't know, don't worry. Like I said, you'll get some of the basic stuff here and the concepts that you'll be able to refer later to those slides. Like there are lots of slides here, lots of links, lots of concepts that hopefully will serve you as a reference in the future. So I'm assuming like you use Celery in your project and you need reliability. So I won't like explain how you install Celery, how you configure on your project or anything like that. I'm assuming like you have a running Celery project. So what are the issues that you probably see? And Celery is your async tasks infrastructure, right? So that's the whole infrastructure that will run your async tasks. And the main thing you want to avoid are lost tasks. So for example, the classic problem of clicking on I forgot my email, sorry, I forgot my password link on some Django site and never receiving that email to reset the password. That's perhaps a classic problem of some async task being lost. The task perhaps to send the reset password email, and that's exactly the thing you want to avoid. And it's very easy to forget because Celery is a great tool and it's very easy to start using it. So it's very easy to forget that Celery is a distributed system. So you are dealing like with multiple moving parts, and those moving parts have to communicate, and they have to communicate correctly. Otherwise, you have task loss. So it's important to remember that Celery involves a web process that will be running your Django application. And there is a broker which will get tasks from the web process and will send those tasks to the worker process that will run those tasks. And there are like task loss risks on this communication workflow. Okay. First of all, let's talk about task loss between the web process and the broker. A task may never be queued due to a broken connection. So the broker has the queue of tasks. The tasks like are queued there, but you may get a situation where the task is never queued because it never reached the broker. Because there is a connection between the web process and the broker, and this connection can fail, right? So it's very surprising that even the simplest of Celery operations can fail, but that's because Celery is a distributed system. So even something as simple as my task dot delay may throw an operational error if the broker is down or unreachable. So you have to think about that because that will not always work. So what your users will see if that happen. We will try accept that error. We will try to roll back any other part of like the view that does that. So you have to consider that, right? Um, it's important to know that Celery will automatically retry task delays. Okay, so I'm not talking right now about task retries. I'm talking about retrying the delay, retrying the queuing of the task. It will retry 3 times, waiting 0.2 seconds between each try. But there is another problem that is not well documented, is that the task commit on the broker side can fail too, even if the connection is fine. So the broker got the task, but for any reason, the commit of the task inside broker's persistent memory, should we say, may not work. So there is a RabbitMQ setting for that. It's called confirm publish true. That means it will take a bit more time to delay tasks, but that will ensure that the task really got inside the broker. And this means you will see operational errors if the task didn't get really queued on broker's queue. So you probably want to set that to true on broker transport options in your Celery setting. It's important to know as well that gigantic tasks can bring down the worker. So it's very common for us, at least on the start of Celery projects, to receive anything as an argument for Celery tasks. And as your project grows, you may end up in a case where you receive 100 gigabytes of data, not in a single task, but like in a bunch of tasks that you've delayed. And that happened to us because we were like processing large XML files and processing that on Django side, and then queuing that to Celery. And because we did that, we were passing like the whole dictionary, the like dictionary representation of those processed XML files as parameters for Celery tasks. And this like exploded the memory of the broker. Actually, not the memory, like the disk memory of the broker. And we got our broker down because of that. So in many cases, you don't want to pass the data values themselves. You want to pass data references. So if you have like a large file that you want a Celery task to process, perhaps you want to upload that to some blob storage like S3, or even your database if you have a proper database for that, or if it's not a super large file. And then the worker will read like the data reference, the ID or the URL of that that data value. You can also lose tasks inside the broker. If you use RabbitMQ, you have to ensure durable queues and persistent messages. This is usually the default, okay, for RabbitMQ, but I cannot like speak that this is true for all the cloud providers out there. So double check that with your cloud provider. And on Redis is more important because you have to be more careful because you have to ensure that you have a proper max memory policy. Redis is more commonly used as a cache than than a Celery broker, right? Than a task queue broker. It's more commonly to use Redis as a cache. So in many cases, Redis installations have a policy that they will start flushing keys if the Redis is out of memory, the Redis server is out of memory. Um, so perhaps you don't want that. Perhaps you want to know that you will not lose tasks, but at the same time stop like queuing new tasks. So you can change the max memory policy to something other than all keys. Okay, so this will mean that your Redis instance will start like rejecting new tasks, but at least you will not lose the ones that's already there. And you may need like to separate Redis instances, right? Perhaps it's better if you like have a Redis instance dedicated to caching that will have like a different max memory policy, one that you can drop keys, drop values, and you should perhaps have other Redis instances as broker and result backend for Celery. And losing tasks, lost tasks can also break user flows. The example that I told before, I didn't get the account verification email, right? So on Django, this is like how this looks like. In this case, a sign up. You have a sign up view, and on the form valid for the sign up view, you have like you get the user, and then on transaction on commit, after the transaction of that view is done, you send the activation email. You delay, you queue a task to send the activation email. I'll explain transaction on commit later why that's necessary. But this is like the regular flow. There's nothing wrong with this, but I just want to show you the regular flow of like delaying a task after sign up, for example. Uh, there is a problem here. In the case of the database has committed the change, like the user sign up is done, but for any kind of reason, the broker is down or the connection fails and the verification email task is lost. Okay, so imagine the broker is down. Depending on how you constructed that on commit, uh, it like the task may not never be delayed. It may get the operational error we talked about because the broker is down. So the database says that the user sign up is done, but the user will never be able like to confirm the email because the task was lost. So there is like a mismatch between the task state and the business logic, right? So you can pass the burden to the end user, like you can put the click here to resend thing that many sites do. But is there a way like for us to ensure auto recovery, a way for like us to figure out that some users never got the email and perhaps send again? And yeah, there is. It's a robust solution, so perhaps not everyone really needs that. But if you really want, that's the best thing you can do. You can source tasks from the database state. So you have your database, and you need to have some sort of task that will pull. The database will keep like making queries to the database to figure out if there are any missing tasks, and then this worker process will requeue those tasks, okay, to the broker, and eventually that worker process or another worker process will get those tasks. And another reason for doing this is if the task infrastructure fails, you have to manually do the consolidation work, right? Depending on how important it is for those tasks to not be lost, someone will have to do that manually. So perhaps why not automating that? So the way you do this is with periodic tasks with Celery beat that will queue other tasks that should have run. So it's a task that queues another task, other tasks, and that task runs periodically, figuring out which tasks need to run by looking at the database. Here's an example, okay? Something that every 5 minutes send activation emails. So it will like filter the user objects, checking if the is verification email sent is false. And if it is, we will delay the task send activation email. Okay. And inside that task, we can set that is task verification email sent true after the email sending is really done. Okay. So if we do that, the worst thing that can happen is like someone getting more than one email, right? But if you do it the right way, like only actually setting the is verification email sent to true after everything is done with the email sending, you'll be able to have something like this that will like automatically requeue any tasks that have been lost. So you can keep the task send activation email on the sign up view. Like you won't have a case of a user waiting 5 minutes. Okay, you can keep that task there because if it works, it will like do the email sending right away, and it would set the email sent to true. So this will like never be resent. But if it fails, eventually after 5 minutes, worst case, that person will get the email. So that's like the more robust solution, and it kind of feels you are doing salary works here, right? But it is what it is. That's what you really need to ensure 100% that you'll never lose that task. You don't really need that for all cases. We rarely do that at Vinta. We only do that for critical business use cases. But it's important to know that you can do something like this. So implementing periodic tasks to consolidating state can be an overkill. It requires development time, it consumes resources. So I would say focus on consolidating the main flows, the main use cases. If sign up is super important to you, perhaps do that. If not, perhaps like just put the button to click here to try again sending, as most people do. I want to talk about Celery Canvas workflows because when I mentioned that problem, many people mention Celery Canvas workflows, which is something like this. When you like have a bunch of tasks that you want to run, and then you want to run another after those all are done. Those are all done. So Celery supports that. Okay, you can build something like this with Celery. It's not difficult. In fact, it's quite elegant to a quite elegant syntax for building this. You declare a task, like the task count words that will receive a document, and we'll do like a simple computation of the number of words in that document. Okay, to split the document and count the length of the list. Then you have a separate task called task sum that receives a list of numbers and returns the sum of the numbers. And you can like consolidate those two, like you can integrate those two in a workflow by building this. Like the syntax is a bit strange at a first glance, but you can check the documentation, it's great. We are iterating over a bunch of documents, calling task count works for each one. Not actually calling, but like building the task. That's the SI. That we mean that we are like preparing that task, and that's called the header, like the list of tasks that we will run in parallel. And then there is the callback, uh, which will like wait for all those tasks to be done to do something with the result of those tasks. And then you build a chord. So a chord is exactly that. So like a map reduce. You like run a bunch of stuff in parallel, get the results, and then call the callback. And if you do something like this in a Celery task, that will be like a Celery Canvas workflow, a map reduce like workflow. And this generally works, but I don't recommend this because it's very, very unreliable. If you search online about Celery Canvas, uh, you will find lots of people complaining about it. There are like 86 open issues related to chords, like many, many open issues in Celery related to that. Many people complaining that want to get away from Celery Canvas book behaviors. That many people find bugs that the Celery chords never resolve correctly, even after all parallel tasks are done. So we also had that issue at many times at Finta, where it was very clear that all parallel tasks were done, but the callback was never called. And Celery overall still struggles when it comes to processing big, complex, long-running workflows. Um, so that's why the first thing I mentioned is like having some sort of consolidation work that you do manually with a pooling task in the database state instead of using Celery Canvas workflows. And okay, but imagine you need to build something like this. You really need to build a reliable, complex workflow of processing the orders of the day. So you have a task to process the orders, then you call a bunch of tasks to process each order. Then you have to wait all of them to be done in order to call send to shipping. That's a real problem we had at Finta, and we tried a lot to use Celery Canvas to solve that, and it never worked correctly until we refactored it to use the database as a source of truth and that kind of pooling that I mentioned. So like the only way we could really get this working reliably with Celery was creating like a order model that will be like the state of each order. And then on process the orders, like we create the order model for each order. And then we trigger a task called process order for each of the orders. Then process order actually does the work to change the order state. And then after our process order is done, we have to run send to shipping, right? But how send to shipping will know that our process order is really done? How is that possible? In the end, the only thing we could do is send to shipping runs continuously, right? It's running like every 5 minutes or every 10 minutes, at least during a period of time of the day that we know that like orders will be processed. And it's a salary bid task. So send to shipping is periodically checking the database, looking at the order model, and checking if the orders of the day were processed. So for example, imagine we know that it takes like 1 hour to process the day orders, and we start processing at, I don't know, 9 p.m. So if you know that it takes about 1 hour, we prepare to run send to shipping every 5 minutes after 10 a.m. 10 p.m. Okay, so at 9 p.m. we start processing everything. We know that it takes more or less 1 hour. So we already pre-configured send to shipping to run like after 10 p.m. every 5 minutes. So it will keep running until everything is done. And once everything is done on the other side, send to shipping can do its work correctly. That's what we had to do. Otherwise, it wouldn't work correctly in all cases because this was something happening every day. And in many, many different days, we had to manually do the consolidation work ourselves. Uh, so yeah, it's difficult to orchestrate complex and long workflows or data-heavy pipelines using Celery in a database. And one thing that we didn't do at Vinta at that time, but we now recommend doing is trying other workflow focused tools. Okay, so if your problem is like a ETL workflow or some business workflow like this, don't use Celery. Okay, Celery is great for like parallelizing Django related work, sending emails or simpler workflows. But like if you have a really critical business workflow, perhaps Celery is not the best tool. Perhaps you need a tool that will have better monitoring, better operability, better handling. You can run anywhere, perhaps on pods, containers, lambdas. And there are tools for that. They are not trivial to integrate with Django, okay? But it will probably be better depending on your use case. So I would say don't start with this, but if it gets complex, move to that before like actually consolidating the work as we did with all that logic of pooling and everything. So there's for generic workflows, there's Prefect, Temporal, and Airflow. And for data-heavy pipelines, you have Daxter and Mage. And most of those tools have like managed cloud offerings. So it's expensive, but at the same time, you get lots of reliability because there is a whole company behind those tools. Okay, we talked a lot about only one of the kinds of losses that can happen. There's also task loss between the broker and the worker, right? So now let's talk about the on-commit thing that I show you. So you have the sign up view, you get the user, and then on after the user is created on the sign up, we send the activation email. Okay. The on-commit is necessary because you can have a situation where you have atomic requests true. An atomic request true is generally recommended in Django, okay? Because you want like your views to either do like the whole work they have to do or do nothing. So if you have a view like that does like the classic example of a debit in an account and a credit in another, you don't want like the debit to work and the credit to fail, right? So you want a transaction wrapping that. So if the credit fails, you roll back the debit. And like, so in general, it's good to have atomic requests true in Django views. But if you have that, you may have a situation where you are calling the task without the transaction on commit, like this, like directly calling the task. And this is quite surprising for folks who didn't work with Celery before, but between the time of sending, queuing the task and actually returning the response, uh, Celery is so fast that if the queues are empty, it can run your task, right? And the strange thing is that it will run a task for a user that doesn't exist yet, because the transaction isn't really done. The view isn't done. Okay, so the user is only actually created on the database after the return response because of atomic request through. Okay, there is a transaction wrapping the whole view. So if you put this without transaction on commit, you may get a situation where the task will fail because the user doesn't exist yet. So you get this, and like you will be wasting a lot of time trying to understand why the user doesn't exist. Because if you look at the database, the user exists. Okay, but the user exists now that you are checking. But between the time the task was queued and then transaction wasn't done, that small amount of time the user didn't exist yet, and the task already had run. So that's the correct fashion. Okay, transaction on commit. If you don't have atomic requests, you may also have that. It will run immediately, so it's not a problem. It will not lose the task if you don't have atomic requests through. Okay, so in general, just use that. There is a situation where you may have multiple tasks, and depending on your use case, you may want to have robust true on transaction on commit. Many people don't know that because that's like a newer thing, is being on Django only for a few years. But now you can pass robust through, and it will be like a best effort if you have like transaction on commit inside of for. It will like delay the tasks that it can, and the ones that it can't, it won't do the delay. Okay, so it will ignore failures on the delay. Um, and another thing that can happen is a mismatch between the task state and the database state. A task can take a long time to execute if the queues are full, right? If there are many other tasks there to be run, and the task that you're putting on the top of the queue will take a long time for the worker to really get it and run it. So in that case, you have to decide. I said before that in general, you should pass the data reference, right? Because especially to avoid like the exploding the broker. But there is this case of full queues that you have to decide what makes sense for your use case, okay? Are you passing the data value or the data reference if you have long queues? For example, charging the credit card. Do you want to charge the credit card that the user currently has, or the credit card that the user will have when the task will run? Okay, so that's quite, that can be different if it takes hours for so it depends. If you are dealing with a situation where you want to get the money at all costs, you charge any card that the user has. If you like don't want users complaining about charging a different card, perhaps just charge the one that you queued first. Okay, so now let's talk about proper removal of tasks from the broker. And the thing is, workers can shut down unexpectedly. And that's quite surprising in many cases. But remember, we are dealing with a distributed system. So all things must be working correctly for everything to work correctly. It's not like anything can fail between the parts of the distributed system. So if anything can fail, when it's safe to drop the task from the broker. So imagine that the broker has a task, okay? And the broker sent that task to the worker. And the worker is thinking that it can handle it, right? But the broker doesn't really know until the worker somehow confirms that it was able to handle the task, right? So what is the right time for us to like drop the task from the broker? Is it like immediately as the worker gets it, right? Or is only after the task is really done on the worker side? Because that's different, right? The task may even take like hours to run. So will the broker drop the task if the worker got it. What if during the task execution, the worker dies or is shut down for any reason, right? What if that happens? That task will be lost, right? So is there like a middle ground solution here for us, like to not lose tasks when the worker dies? Uh, so if you like send eat cake to the worker and for some reason the worker doesn't have enough RAM and explodes and loses the task, if immediately after sending the task to the worker, the broker drops the task, if we do that, that task will be lost, right? The broker won't have it anymore, and the worker process like restarted and lost the task. Uh, Many restarts can be graceful, right? So there are situations where the worker can like send the tasks back to the broker, right? But the worker is like a computer, a machine. Someone someone might just pull the plug, right? It may explode. Something may happen like catastrophically, and the worker won't have time to send the tasks back. Okay, so it's very common for like not enough run problem to happen, and the worker will just die. It won't have time to send the tasks back because the operating system will just kill the process that's misbehaving using lots of RAM or something like that. So nothing is 100% reliable. Even cloud containers will fail from time to time. It's even expected for them to fail from time to time. There is an SLA, right? And it's not 100%. And bad test code can also kill a worker without the opportunity to gracefully handle any exceptions. So huge memory usage is a clear example. And there's even the case where you are causing worker shutdowns. Depending on how you configure your deploys, you may be interrupting your worker processes when you are refreshing the containers or restarting the processes on a deploy. So perhaps you are doing that and don't even know, right? You are killing the workers and causing tasks to be lost. Okay, so when eat cake tasks should be dropped from the broker? Right after the worker gets it. If we do that, the worker can lose the task. Okay, and that's the default. That's the default of Celery. It kind of assumes the workers will well behave, and that means task axlate is false. That's the configuration, axlate false. So immediately when getting the task from the broker, the worker will acknowledge the task. We'll send an acknowledgement to the broker saying, I have the task, forget about it. But we can change that behavior, and I actually think everyone should change that behavior to axlate true, which means that after the worker finishes the task, the worker will send the acknowledgement to the broker, and only after that happens, only after the task is done, the task is removed from the broker side. And what happens if the worker fails? If the worker fails, the broker will automatically redeliver the task. So you have a much more reliable system if you have axlate true. The tasks will be automatically redelivered if workers fail. Okay, so for reliability, we have to set task axlate true. That means that the broker will wait for the worker's acknowledgement to drop the task. So if the worker dies, broker still have the cake, and it will redeliver the eat cake task. Okay. Okay, but if tasks can be automatically redelivered, now you, the coder, have to ensure that your tasks are safely retriable. Okay, it is possible to redo the task even if some work has been done without having any negative side effects. So your tasks need to be idempotent. It shouldn't matter if the task is executed repeatedly with the same arguments, because there should be no harmful side effects. That means you have to be careful when writing task code. You have like to use get or create, update or create, depend on what you're doing. Like the work you are doing must be idempotent. You have to be able to rerun it again, like with the same arguments, and the effect should be the same. Okay, because you may get a situation where mid-execution, the task was lost, and now the broker will redeliver the task and the worker will rerun the task, okay? And for making tasks independent, you may need atomicity, right? You may need to wrap your tasks in transaction atomic. So if they are interrupted, the database will automatically roll back any changes, right? And you have to beware any side effects that are impossible to roll back, such as sending an email, right? You cannot undo that. But in general, we don't care much about emails. You just send repeated ones. That's not a huge deal. But you may have other side effects that are impossible to roll back or difficult to roll back, like charging a customer. So you should perhaps couple that with database state change and rollback if fails, and only like actually do the thing that you want to do at the end, like after like everything is done and the database has written, then you do the work and then you commit the change. And you perhaps can also keep tasks short and fast for reliable retries. So if you reduce the amount of code in your tasks, it will make much easier to have those tasks retriable. Okay, so how this redelivery really works, right? The tasks, the task stays on broker queue unacknowledged, and the worker failed. How the broker knows it's time to redeliver the task? How that really works, right? On RabbitMQ, that works really great because there is a connection between the the broker and each worker. Okay, you can have multiple workers. So when like this connection drops, that means like the worker process is lost. Like it reset, the machine was shut down, anything. So when the connection is lost, the RabbitMQ knows that, okay, I just sent like 3 tasks to that worker. I never got the acknowledgement for those tasks. Now I have to redeliver them, right? Because they weren't done. They were interrupted because the worker has died. On SQS, like AWS SQS or Redis, like the other two most common brokers for Celery, you have a concept called visibility timeout, which is not as great as RabbitMQ and is the source of many Celery issues. Many people like get really confused about that and ask on Stack Overflow and everything. And what is this? If the task is not acknowledged after a certain amount of seconds, it's automatically redelivered. Okay. And the default is 30 minutes for SQS and 1 hour for Redis. So more careful people might already figure out that you now cannot have any task that takes longer than 1 hour in Redis, right? Because if your task takes longer than 1 hour, it will be redelivered, right? The worker never acknowledged that task because late is true. So that's like a huge problem that many people don't know about. And it's really sad because this only bites you after your project grows really large, right? And you start having like long tasks, long and complex tasks. So you can change that, okay? You can change that to more than 1 hour. Here is 3600 seconds, right? 1 hour. But you can like increase that with that setting, broker transport options visibility timeout. There is a maximum amount that SQS and Redis will support. Check that, but you can increase that if you want. The trouble is there is a trade-off, right? After the visibility timeout, the task is automatically redelivered, even if the worker is still doing the task, right? So that's a problem. And then no task can take longer than the visibility timeout. But at the same time, if you increase the visibility timeout, the tasks will take more time to be redelivered. Right, so the visibility timeout should be like a bit more than your longest task. The problem is your longest task will change over time, so you have to keep an eye on that. And there is this trade-off for fast redelivered versus long task support that you have to care about and monitor. Otherwise, you have issues. So my recommendation is just use RabbitMQ. In general, it's more expensive, like to use than Redis and SQS because like the cloud offerings are more expensive, but it's much more reliable. So stick with RabbitMQ as a broker. It doesn't need a visibility timeout. Another alternative is to not use Celery for workflows of long tasks, as we mentioned before. And another solution is task isolate false. That means no visibility timeout is needed, but that means you have lost tasks if the worker, if any worker gets interrupted, right? As we discussed before. So there is this trade-off. And this is not a problem about Celery, okay? It's worth mentioning that. Any sort of distributed system for async tasks has this sort of problem. So SKS is an Amazon tool, and it's used in other async task frameworks that are not Celery, and it has the same problem, right? So it's not a problem of Celery itself. It's a problem in general of distributed system. How we really know that something was lost. You either keep a connection between the things you are dealing with. That's what RabbitMQ does, or you keep some sort of visibility timeout. Okay, there is like more stuff here. I won't like dive much deeper than that. I'll just like go quicker here, but you have the slides for reference later on. I want to mention a few more surprising stuff that you find on Celery. Is that one of it is that tasks are intentionally dropped when worker failure. Okay, why that happens? Because if Celery is able to detect that a task caused the worker to die, okay, due to segmentation faults, out of memory errors, Celery considers that task to be a poison pill, okay, something that kills workers, and it rejects that task. And that means task reject on worker lost is false by default. And the problem with the naming is confusing, okay, but it's really what I meant. If the task kills the worker, the task will be dropped. It will not run again, okay. And that this is a protection, okay, that Celery does to avoid like a task that will always kill your workers because it's like a task for processing a gigantic XML, for example. It will never be done. Like every time it will execute, it will kill the whole worker. So Celery will just drop that task. It will reject it because it calls the OS, the operating system, to kill the process due to like segmentation faults or out of memory errors. And what you can do is to change that to true, okay? And that means you have automatic redeliver in all cases, even if the task causes the worker to fail, okay? And but like this in general is not recommended because you may have a situation where something is misbehaved or misconfigured, or even a library you use has a vulnerability that causes the worker to die. And you don't want that like to be killing your workers, and now you don't know why your tasks aren't running, right? And your queues are getting large. So there's a middle ground for like very critical tasks. You can have reject on worker loss true. That means like that task will be always redelivered even if the worker fails. And do that on tasks that you know are well behaved, or like simple API calls or something like that. You don't want that to like be lost never, even if the worker fails. So just put that as true on those critical tasks. And handling exceptions is also necessary. Task isolate true only solves unexpected shutdowns and reject on worker loss as well. If a task raises an exception, it's still acknowledged. So the task is considered done if it raises an exception. So if you have like cake, objects get unicorn cake doesn't exist, it throws cake does not exist exception, and the task is gone. This is because the default is task X on failure or timeout is true. You can change that if you want, but I don't recommend that. I recommend you to explicitly handle all possible exceptions, because that's what you should do already on Django views, right? Your Django views shouldn't throw 500 errors. So do the same on Celery. Everything that can throw exception, catch that and decide, do you want to retry the task? And there is like a solution for that in Celery, or do you want to drop the task if the exception happened? So decide and implement what you really want. So I don't want to dive much deeper than that. I want like to open up for questions. There's a bit more stuff here that you can check later. The only other thing that I want to say is that tasks with ETA and countdowns are not what you expect. Okay, so if you do something like this, where you delay a task to run 1 hour from now, that's not what you expect in the sense of the task will not stay on the queue and then will go from the broker queue to the worker after 1 hour. What really happens is something really strange. The task is fetched by the workers and it stays on worker memory for 1 hour until it's the time for the task to run. Okay, so there's a lot of trouble to that. First of all, the visibility timeout, right? The visibility timeout to start counting immediately. So you have to consider your visibility timeout with the countdowns you have on your longer countdowns. So it basically doesn't work, right? You shouldn't have any countdown larger than like a few minutes. That's actually what Celery really recommends on the docs. And it's really there like just a small message, but is that you shouldn't like put anything longer than several minutes. If you really want to do that, you should like use database bucket periodic tasks. So basically the same thing we already discussed. You have something that checks if something should run and triggers those tasks if they should run. So yeah, just wanted to mention that. And you can check like those slides for more issues. The other ones are less common. And I have like this gist with the recommended Celery settings for reliability. If you just want, okay, Flavio, I just want like to set all those settings to my project and don't have any issues with that. There are like recommended settings that I've put together. But just remember, you still have to do some work, right? You have to put retries. You have like to ensure independency. You have like to use the on commit that I mentioned. So there is some work for you to do in any case, but those settings will hopefully help you a lot. Okay, that's it. Thank you, and please feel free to reach me. Here's you can check my email on my Linktree. There's my Twitter as well, and I'm open for questions.
Thank you, Flavio. That was a really excellent lot of information there, a lot of interesting thinking there, and I think we have at least one question. So we do have some time for questions. If folks have anything, feel free to raise your hand and we'll take anything that comes up. And Lamont, I see you've got your hand up. Lamont, are you able to unmute? You should be able to.
There we go. Thanks, Flavio. That's a great presentation. One of the things that distinguishes what we do is to have a number of child processes that are kind of running a pyramid. And one of the issues that we see is recovery. And you gave us a lot of options. It didn't look like Celery had any method for actually recovering, and I didn't know in the other tools, and we use Kafka, things like that. So what would you recommend for that?
By recovery, you mean if the worker processes die, they will like auto restart, right?
Exactly. Or you fix something and then you restart the process. I mean, there could, in some of these situations, you could have 50 processes sitting there waiting either to start or to redo that run that failed.
Yeah, first thing I would do is like try to figure out why those processes are really dying. Like I would say that's probably some misbehaved task like that uses lots of memory or something like that. Or maybe some library that isn't great and has like segmentation faults. Many performance related libraries on Python have that. Like if you're using something to process files, XMLs, or even like some specific NumPy libraries may have issues uh, with memory handling, and you may have issues that will kill your workers. I like the way we do that at Vinta in general is like to use containers as workers, like the wrap worker processes on containers. So the container management of the cloud will really like ensure that there's a number of containers always running. Uh, and then we have like health checks that ensure the containers are alive and will like restart the containers or auto scale them if necessary. I know like there are tools that you can use if you have your own like bare metal machines, you can, or your own VMs. You can have like supervisor D or something like that to ensure like those processes are auto restarted. Uh, and on Kubernetes, you like also have many solutions for that. So I don't have like a clear answer. It depends on where things are running. So what I will do is like actually analyze why those things are failing because they shouldn't, right? And use some sort of like supervisor tool, or even like if you're using containers, configure how your containers should do the health check and auto restart and auto scale.
Yeah, terrific. Thanks.
Cool.
Have any other questions? You know, that was a lot to digest. So if there are not, then we'll start winding the presentations down. I'm going to go ahead and stop the recording now.